No? Don't give them the benefit of the doubt? All right, they just watch for fun. I gotcha. Brecken made the rules. Here we go. You don't have to write this down. Please just follow along so you can understand where the heck all this stuff is coming from that we're doing today. You did learn what sine of a plus b is, right? We expanded that to the sine of a times the cosine of b plus the cosine of a times the sine of b. You guys remember doing that on Thursday? Well, today's question is, what if a and b are the same? So what if we replace b with a? Then all of a sudden this becomes cosine of a and this becomes sine of a, right? Well, aren't those two things exactly the same then? So you just get two of those. So if it's sine of two a's, or a double angle, it can be simplified to that. You have to write that down. We're going to do that together in a little bit. But then this piece right here, same thing for cosine. So we've got the cosine of angle A times the cosine of angle B minus the sine of angle A times the sine of angle B. Watch what happens if we change this B to A. Cosine of A times cosine of A is cosine squared of A. And sine of A times sine of A is sine squared of A, isn't it? So cosine of a double angle becomes that. Some people say that they want to substitute something in. For example, you guys remember that cosine squared is the same as 1 minus sine squared. And if you put that in there, you get a 1 minus 2 sine squared. And some people go further. They say, well, I want to substitute a 1 minus cosine squared in for that. And if they do that, they get cosine squared minus a negative cosine squared, which is 2 cosine squared minus a 1. So this one ends up having 1, 2, 3 formulas. This one just has 1. And so the formulas that we're going to use today, and here's where you can start writing it down, is we want to know the double angle formula for sine of 2a. So if you have twice an angle, that's equal to, we could convert it to a single angle, it's 2 times the sine of a times the cosine of a. And again, that comes straight from our addition subtraction formulas that we just listed out.
Oh, Nevaeh's FaceTiming me. That's weird.
Yeah, bring her on in.
Here's half your class.
Yeah, well, not half, but
We can't hear you.
you. What do you mean? Nobody's ever told me in their life that they can't hear me. It's usually I'm talking too loud.
Oh, now I can hear you.
All right, well, welcome. Do you want to tune into our math lesson, or are you just here to talk about how you guys are doing all sorts of fun stuff without us?
No, we're just eating lunch. We're eating lunch.
Well, good for you guys. You continue to work hard. We're going to go over some double angle theorems, okay?
Okay.
Maybe we'll record the lesson for you, maybe we won't.
Okay.
If it's cosine of a double angle, we wrote these formulas down as well. We've got cosine squared of an angle minus sine squared of an angle. We also showed the second formula you can get. You could also use 2 cosine squared of an angle minus 1. Or you could use the third formula, which is 1 minus 2 sine squared of an angle. I happen to like that one the best. I like that one the best. If you flip to your very back page of notes, you're going to see this formula sheet right here. And on that formula sheet, notice that right now we are sitting in the double angle formula option. This is the box that we're working in. So that's what you get to use on the test. Notice it says sine of 2a is equal to that. And then cosine of 2a, you have 3 options. You have option number 1, option number 2, or option number 3. I like to use number 3. Okay? So we go to our tangent option. And the tangent option, tangent of twice an angle, is equal to 2 tangent of the angle divided by 1 minus tangent squared of the angle. I don't like to use that formula. I've never used that formula before in any math class moving forward. Do you agree if we never see it moving forward, it's probably not important to use? So therefore, I use a formula that I do use. I use instead sine of a double angle divided by cosine of the double angle. That's what I choose to use. And I would use that instead. So this is we start to get some of the IDK problems on the test. You guys know how I feel about the IDK situation, so please avoid that. But this is the one example we're going to go through today. We're going to get you to your assignment, okay? And it says to determine sine of a double angle, cosine of a double angle, and tangent of a double angle. So when you get this, don't just write down a big question mark. Actually write down sine of 2x, write down cosine of 2x, and write down tangent of 2x. Those are the three things we're trying to compute. Do we have formulas for those three things? Sure. Sine of 2x is simply 2 times the sine of x times the cosine of x. And the cosine of 2x is 1 minus 2 sine squared of x. So we'll do the tangent one in a second, but already you're giving me an indication as a student you have a general idea where to start. Now, in order to get the first point, I could probably give you about half a point for setting that up. At least you wrote down some formulas. Out of 4 points, I gave you about half a point. But to get a full point, you're going to have to at least do this part, okay? I have 2 times. I already know the sine or the cosine value. Which one do I know and why?
Sine.
Why?
Well, you have the cosecant.
It says cosecant is 2. So if cosecant is 2, then sine is 1/2. So now I need to come up with cosine. Is there a formula that we have where if you know sine, you can then determine cosine? Most important formula of all trigonometry? Sine squared plus cosine squared is 1. So let us use that. Sine squared of x plus cosine squared of x is equal to 1. So I'm going to take my sine value and square it. My sine value is 1/2. I square it and I get 1/4. Plus cosine squared of x is equal to, and instead of 1, I'm going to write 4/4. I subtract that 1/4 and I get cosine squared of x is equal to 3/4. Now what? Square root both sides. I have cosine of x is equal to, remember your plus or your minus. The square of the top is the square root of 3, and the bottom is 2. Is it positive or is it negative?
Negative.
Why?
It's in the second quadrant.
If you're in the second quadrant, cosine is negative and sine is positive. So I have 2 over 1 times 1 over 2 times negative root of 3 over 2. Notice that the 2's cancel, and I'm just left with negative root of 3 over 2. That's the hardest part. Now, it's easy the rest of the way because you already know what sine is. You have 1 minus 2 times the sine value is 1/2. I'm going to plug in sine squared. What is sine squared? 1/4. I'm going to write this out because it's a mistake multiple people made today as they've come in and asked me homework questions already. It's 2 over 1 times 1 over 4. Okay, you don't multiply the top and bottom by 2. You multiply just the top by 2. As you end up with 1 minus what? 2/4 or 1/2, which reduces to 1/2. So 1/2 is that answer. In order to come up with sine of 2x, you take, or tangent of 2x, take sine of 2x divided by cosine of 2x. Here's another point of confusion. For sine, I don't grab 1/2. That's sine of x. I want sine of 2x. Sine of 2x is that. So I have negative root of 3 over 2 divided by, yeah, notice for cosine, I don't grab negative root of 3 over 2. That is cosine of x. I want cosine of 2x, so 1/2. When you divide, you multiply by the reciprocal. Notice that the 2's cancel. I get negative root of 3. Now, as we're ready to move on from this and kind of steer you in the right direction for your homework, I have a question for you. Is sine positive or negative in the second quadrant? Positive. Is cosine positive or negative in the second quadrant? Negative. Why are my sine and cosine values backwards? Parents share, see what you come up with. Think of anything. Talk about it. Why? Go. Is it?
There's 2A. Double A, yeah. I don't know. There's 2, there's double A, those so.
That is in the second quadrant.
So if there was negative, so cosine was negative, and sine was positive, and many times by that, the cosine would make the sine negative. Because if it's negative, then cosine, or sine's negative.
Okay, 5, 4, 3, 2, 1. I heard somebody kind of talk about it a little bit maybe, and the fact is that this angle x is in the second quadrant. Does that mean that 2x is in the second quadrant? Absolutely not. In fact, in this situation, you could show that x is actually 150 degrees. So then what would 2x be equal to? If x is 150, then 2x would be 300. What quadrant is that? Fourth quadrant. And sine is negative in the fourth quadrant. Cosine is positive in the fourth quadrant. And tangent is negative in the fourth quadrant. So remember that your final answer doesn't need to pair up with that. That make sense? Okay, take out your homework. Let me give you a little bit of guidance here. Problem number 1 for your homework, as you look at that page that has just 3 problems on the front right here, okay? Those 3 problems on the front. I want you to know that problem 1 usually goes very well for people. For problem 2, look at what you're given. Are you given that sine or cosine is equal to something? You're given that tangent is equal to negative 4 over 3. So then you cannot use sine squared plus cosine squared is equal to 1 because you're given tangent. So instead you must use a new formula. And that would be 1 plus tangent squared is equal to secant squared. So in our example, we use the sine squared plus cosine squared is 1, and that probably going to have to use that. And then problem 3, I don't like the problem, so please change it to cosine of x is equal to 7 over 25, 7 over 25. And then it does say that cosecant of theta is less than 0. So you could continue, or cosecant of x, excuse me. Sorry about that. Okay, on the back side, problems 4 through 7 should be short problems. And I mean short. If you spend over 5 minutes looking at those, stop. I don't want to give away how those work out. Hopefully you can see them through pretty quickly. If you can't, we'll talk about them tomorrow. But don't spend too much time on problems 4 through 7. They're intended to be pretty quick ones. So, but I would encourage you, try to get number 1 knocked out before you leave class today. You got about 7 minutes. It'd be good to try to see that one through. And then tomorrow we will finish by be able to get you up to speed on problems 8, 9, and 10. Okay, so go ahead and take some time.